Welcome to day 3 of complex numbers. A couple more days of material, review, and an assessment, and that will pretty much take us to the end of the trimester. One little project for you at the end. So today we're going to look at powers of I. So we already know, we've already defined that I is equal to the square root of -1, and I squared is equal to -1. So what happens if we raise the powers? So we know I is the square root of -1. If we see the square root of -1, we're just going to write I. I squared is -1. I to the third power is the same as I squared times I. So it's -1I, or -I. I to the fourth is I squared times I squared, or -1 times -1. And -1 times -1 is +1. When we get to larger powers like I to the fifth is the same as I to the fourth times I. So I to the fourth is just 1 times I, which is I. I to the sixth is I to the fourth times I squared. 1 times -1, which is just -1. I to the seventh is I to the fourth times I to the third, which is 1 times the opposite of I, which is just the opposite of I. And I to the eighth is I to the fourth times I to the fourth, which is 1 times 1, or 1. Notice these first two columns. I, -1, -I, +1. These powers form a cycle. Every 4 powers repeats. So if you get I to the ninth, that would be I to the eighth times I. I to the eighth from the previous column is 1 times I, which is I. I to the 10th, a couple ways you could do that one. You could do I to the 8th, which I always like to do powers of 4, because we get 1 when we have a multiple power of 4. And then we'd have I squared, which is 1 times -1. And so you can see in this row all -1s. I to the 11th is I to the 8th times I cubed, which is 1 times the opposite of I. And I to the 12th is I to the 8th times I to the 4th, 1 times 1, which is 1. So a couple of examples. Again, if you need, pause the video and work these out, and then restart the video once you've got your answers. To simplify the powers of I, we have I to the 18th and I to the 24th. So again, I like to break things down into multiples of 4 for the power. So 18 would be 16, which is a multiple of 4, and it would leave us with 2 powers of I left. I to the 16th is going to be 1. I squared is -1. So we would get -1 as our answer. I to the 24th is evenly divisible by 4. So we don't need to break it down. Anytime we have a power evenly divisible by 4, we're going to get an answer of 1. All right, the next thing we're going to talk about is a conjugate. Special notation for a conjugate. If we start with a complex number, z, which is equal to a plus bi, its conjugate, noted by z bar, little line above the z, is defined as z bar, which is a plus bi bar, is the same as a minus bi. So a few examples. 2 plus 3i bar, the conjugate of 2 plus 3i, is 2 minus 3i. Negative 6 minus 2i bar, or the conjugate for negative 6 minus 2i, is negative 6 plus 2i. Very simply, when you're finding the conjugate, you simply change the sign between the real part and the imaginary part. Everything else stays the same. So again, we're going to find the conjugate. Find the conjugate of each complex number. Again, pause the video, work these out, restart the video. So the conjugate for 2 minus 4i, which we could also write as 2 minus 4i bar. Change the sign in between. Everything else stays the same. 3 plus 7i, or 3 plus 7i bar, is 3 minus 7i. Negative 5 plus 2i, or negative 5 plus 2i bar, is negative 5. Change plus to minus, 2i. And one that's a little trickier maybe, 9i. Well, 9i is the same as 0 plus 9i. And then we put the bar over it. So we could write it as 0 minus 9i. And usually we don't write the 0, so negative 9i is the conjugate of positive 9i. So you have an assignment on conjugates. It'll be on Schoology. Good luck. I think you'll do fine. I think you'll do terrific on it. We'll see you for the next lesson.